Okay, on the graph of f in the figure below, first of all, the first big warning is I use the same graphs often, and I might just label it differently. So don't assume just because you see the same graph that it's the same question. Make sure you always read the question. On the graph of f in the figure below, indicate the x values that are critical points or points of inflection. Label whether they're max, mins, or point of inflection, and on top of that, then graph f prime, and then it asks the next grid below, it says plot the second derivative. So first, let's just look. This has got to be a max. That's really easy. This has got to be a min. Okay, people very rarely miss that part of the question. Now, what about points of inflection? So you want to look about where the spilling water and holding water is changing. So from down below, down here, all the way up to roughly here, you have a spill water situation. Up until here, you have a hold water situation. Then roughly here, it would split, and you'd have a spill and then a hold. So you'd have a spill, hold, spill, hold. So it's just a bowl is going up or a bowl is facing down. Okay, so all these guys have to be points of inflection, right where the spill holds move. Now, this particular point of inflection is also a critical point, but you know, it's more important that you label it as a point of inflection. But if you zoom in, you would be able to tell that that's actually horizontal tangent line also. But that's less important because this is a visual question. If you were doing this algebraically, then you'd absolutely have figured out that was a critical point. But it's visual, so you can't necessarily tell if that's completely flat or tipping downward. Okay, then on top of the plot, I'm going to switch colors here to, let's say, green. So if you remember f plot, then the x-axis doesn't matter as far as plotting derivatives and whatnot. But the f prime plot, the x-axis matters a lot. Okay, and also f double prime, etc. All the other derivatives. The axis matters a lot in those cases. But for the original function, you can lift that function or let it sink, and it's not making any difference to the derivative. Wherever the maxes are in f, they are going to become zeros in the f prime plot, and any mins are going to become zeros. And over here, even if you did not realize that this was a zero, even if you put the point here, that would be okay, because then I would say, aha, actually, in fact, rather, if you put it there, it would be okay. Because you may have interpreted that as gently sloping downward, in which case I would expect you to have almost zero, or you can interpret that as being horizontal, in which case I expect you to actually put that point there. Okay, now your maxes and mins and these other points of these other critical points, they will split the plot into these zones. Okay, in the first zone, the curve is strictly increasing or strictly decreasing. So in this first zone right here, we are strictly increasing. That means f prime is positive. Here we're strictly decreasing, so f prime is negative. Aha, f prime is still negative, and here f prime is positive. So what we're going to do is we're just going to say positive, negative, negative, and positive. Now the other thing that should happen, which I'm less concerned about, is that right here this should be the min, which, you know, I didn't do it correctly. Because, you know, we're not necessarily being as careful as we should be. But this should be the min. Yeah, it should be like that. And then I would try to get rid of this here. There we go. Okay, so that's the best we can do for that. Let's see. Right, now the next question says, down below, plot f double prime. So what you want to do is keep track now of where all the maxes and mins are for this guy. And those are going to become important in the next plot. So the 3 points I circled are, there's 2 mins and a max in F prime. So those should become zeros in F double prime. So I'm having a hard time adjusting. It's because there's so many pages in this document. So there should be a 0 there. And just around 0.5 maybe, we should have another negative 0.5. Well, then we look at the, again, it's hard only because I'm having trouble adjusting the screen. Okay, and so down below you're going to have a zone here. So you're going to have 3 zones down below. It's going to be negative, positive, negative. And that's the only part I really care about. It's going to be negative, positive, wait a minute. Negative, positive, negative, positive. There we go. Negative, positive, negative, positive. There, and that's all you need. That's all you need. Now, it does not ask, but you should ask what's the degrees of all these guys. So F double prime goes up, down, up. It's a cubic, right? It's going to be a cubic at least. And so when I say cubic at least, it's probably a cubic, but we could hide other roots in there so you couldn't see them, but I'm not going to. But I'm just going to say, you have to say that this has to be at least a cubic because it has 3 roots, or because it wiggles up, down, up. So there's different ways you could figure out that. So F prime has to be degree 4 or more, and F has to be degree 5 or more. Okay? That's about all you need to know for that.